we go for the logistic regression. So linear regression means we are predicting values. For example, price, stock market. Okay, if you want to predict the stock values, okay, in kind those kind of when you are using that kind of values, scalar values, then you can go for linear regression. When you there is some other applications like classification, whether the customer will purchase this or not. The output will be only two things: yes or no, isn't it? So there is some application like this: whether this student pass or not, whether this customer purchase, whether they take the insurance or not, who will take the insurance, based on what? Okay, so in those kind of applications, there's a lot of applications like this. We go for this logistic regression. So it is the output is basically binary classification, either 0 or 1. Okay, spam detection, whether the mail is spam or not, whether this person is diagnosed with disease or not, has cancer or not, has heart disease or not, based on their blood report, based on the BP, based on the sugar. Okay, so in those applications, this logistic regression is very, very useful. So it is basically a probability functions. Okay, your 0 or 1 is based on the probability. For example, here is one example. The insurance company needs to find out whether, because the insurance company having the database now, the insurance company has to find out whether this customer will take health. Simple, here also there will be simple as well as multiple. Simple means based on one criteria or one independent variable. Here only one, that is age. So based on the age, whether you will take the insurance or not. So lower the age, higher the probability. So that is the linear relationship between this. Because when we become older, we look for the insurance. The probability of choosing the insurance is high. When you are young, probably you will not take up the insurance at that time, isn't it? So there will be some linear relationship between the age as well as the insurance. So first we'll take that. And this is the output of the model. So there you will have the linear line. Here you will have yes or no, 0 or 1, whether taking up or not. So here you have a sigmoid function. There you will have linear line. Okay, y b0 plus b1 x1. Here it is a probability function. Here also there is some linearity. Linearity is there. b0 plus b1. Okay, mostly it is a probability. So this p is nothing but this curve sigmoid. And for example, we are going to predict at the age of 35, at the age of 45, a customer at the age of 35 and a customer at the age of 45, whether he will take the insurance or not. So when you project that, it comes to this point here, it is a 42%. 42% says 42% he will take up the insurance. Above 45, yeah, 81% he will take up the insurance. So you have one threshold line. This threshold line says that below 50%. So because it is a point, it is not 0, is not willing to take, is not the customer, he will not take, he will take, but 42% he will take. Okay. So 42%, since it is 42%, we will put that customer in the no category. It is above 50, we will put the customer in the yes category. Okay. So based on the probability function, percentage of probability, we will put that the customer either in the 0 or in the 1 category. So that's the main area. So for modeling better, the insurance, taking up the insurance not only on the age, it also depends on the income, and it also depends on the level of education, and it also depends on the family. So I'm taking 4 variables, okay, and I'm going to create one model. So this is an example, okay. So here again, there is a line, no linear line. So there will be mean square error optimization we have seen there. Here it is a maximum likelihood function. Okay, so what is that maximum likelihood function? The best curve with minimum likelihood, with maximum likelihood. So there will be lots of curves. Similarly, like linear regression, there will be lots of lines. Okay, we'll choose the best line. Here also we'll choose the best sigmoid. The best is depends on the maximum likelihood function. The maximum your curve matches with the values is taken as a best curve. So compared to the other curves. So based on the likelihood function. So this is the mathematical concept behind this. Okay, we'll move on to the implementation part. So I've given one more algorithm. So Okay. So these are the steps. Okay, I have converted that into steps. So your code, complete code has been converted into steps. Now you can able to understand the code better. So that's why I separated like this one. First importing the libraries. Before that, I will explain what is our project. So without connection, you cannot upload anything on. You can't work on the Google Colab notebook. Next, I'm going for social network ad. So what is that? You just open it and so what is this social network ad is? A car company has a database. Okay, so it has 400 entries and there is an age as well as estimated salary and whether the person has purchased the car or not. So this is the database of the car company who launched the car way back. So for example, the car company launched one car 5 years back. After 5 years back, they have some databases in it. So they are launching one new car and they want to predict who are the candidate can able to buy that car for the previous based on the previous. Okay, so who are the customers purchase that car is based on age as well as estimated. So it's a multi-dimensional, multiple logistic regression. Okay. So based on the salaries as well as age, and you have purchase whether 0 means not purchase, 1 means purchase. So this is the data. Based on this, they are after that they want to see what are the customers they can target based on the they will identify what are the customers they can target to advertise the product to them and make them to purchase. Okay, so they cannot advertise to all, isn't it? So they will choose a customers who can able to purchase based on their experience. Now, as usual, we are going to create one code sheet and we are going to import the same thing. Okay, so these three algorithms are mainly used for machine learning for pre-processing. Okay, if you want to analyze the data set, then these three algorithms. And then the next part is we have to import the algorithms. That is the next part. Just import it. So now you will understand better all those pre-processing steps. Maybe it may not be difficult for you now. Initially, you may face some difficulties. Here you can see the data set I log, the same values. You know what is that? Except the last column, everything is in the X. The last column is in the Y. If you want to see that, just type X and then see it. And then splitting the training set as data set. So this is also common. 20% basically will take for testing. Here I am putting some 20%. So that's up to you because there is test size also. So more the data, the model will be perfect. Okay, there will be some inaccuracies will be there. You may thought why it is not accurate, the multiple, because the data set is very, very limited. If you have more 1,000, 2,000 data set also, it will learn fast. Then your prediction will be better. Okay, that's the basic thing. Next, I'm just moving fast. If you want to see all the data, view all the data sets, what is extrain? If you want to view means you can see extrain is nothing but age and salaries. Y means can print extrain or Y train means all the outputs, whether he is purchasing or not. All those things you can visualize. X test. Okay. So now I'm not interested in that because I'm interested in feature scale. So this is the new thing you are going to learn. Very important thing. Okay. Now listen, why we need to go for scaling? Okay. Import standard scalar. Okay. And we are creating the variable for standard scalar SSP. Model is created. And we are going to train that fit transform to the value of X train. Okay. After that, I'm going to do for S test. Now, you can see the difference between why we are going for scaling. Okay. That is a question. You can see here, estimated salary is in the lakhs and thousands. Okay. Age is in the 25 and 35. So it is the difference between these two is very high. If you create a model based exactly with these values, salary impact will be more on the prediction when compared to age, because age is varies. The machine will learn only numbers. It doesn't know it is a age, it doesn't know it is a salary. Huge number of values in one side and less number of values in the other side. The machine may take the impact will be the output prediction will be mostly based on the salary, because this had a huge impact on the prediction when compared to age. If you take as it is. So that's why this scalar is very, very important. When you apply the scalar in the explain, the explain means nothing but the age and the estimator. These two will be limited to a particular values. For example, -1 to -1. So there's some standard. I think that only your estimated salary as well as your age will be converted. So let's see how it is. So I've already trained this one. So I will see what is X train. Just copy this X train and paste it. You can see now. Okay, so your values, extreme values will be, extreme means this is age and this is estimated salary. You can see the age and estimated salaries is between 7, I think 10 to 10, I think -10 to +10. Okay, so some zeros will be there. So it is converted into a standard value. So this is called scaling. Okay. Before that, it is not the case. It is in the thousands, lakhs, and another thing is in the hundreds. So after the pre-processing is over, the next part is we are going to training the algorithm. Our training the algorithm is same part. Only thing is here we are using logistic, there we are using linear. As a linear model. Here also is the logistic. Again, random state. Why I am using random state means we both should get the same result. So when you apply random zeros for learning purpose, the same values will be taken. The model will be work on the same values. And then fit. Fit means training. Here instead of regression, I'm taking the model name as classifier. Remember that. And then X train and Y train, and this the model has been created with a random state 0. Okay. And predicting the new result. So I'm going to predicting the new result. Okay, we'll predict. So as again, this is the model created. Predict. We are going to predict, and we are going to use this FC transform. Why are we using the FC transform? Because we are going to give as input age and salary. So we need to use again the same SC transform, so that it will convert that age into salary into the standard scalar value. Okay. So this is the new value, 8,700, and it is saying he will purchase. Okay, 30,700. It's saying he will purchase. Okay. So that is the model that we are created. So we will give you some other values also. For example, 25, and the salary is I will put less 6,000, 16,000. Then they are purchasing. So it is the training is based on the model. So we may think 16,000 how we purchase. So we have to analyze the data set. Based on the data set only, it is predicting. Okay. Maybe the age criteria also there. Okay, because it is a 2-dimension. So like that we can analyze the data for values. Predicting the test set. So now, so different values. Now I can test with the test set itself. Test means 20% of the data I have taken, and I am concatenate the original value with the test value with the predicted value. So here you can see 0, 0, 1, 1, 0, 0, 1, 1. So that means the prediction is almost fine. The predicted value is 0. The data in the Actual data set is also 0. That means your model is working good. Okay. Here is different. 0, 1. The predicted is 0, but the actual value in the data set is 1. So that means there is some difference. It's not 100%. You will not get 100%. And then confusion matrix. So this is another parameter. You have to learn this confusion matrix. So what is that confusion matrix is? So you can see here. Predicted. So if the predicted value is positive, that means 0 or 1. Okay, positive means 1 will take. And the actual value is also 1. So that means your prediction is correct. And if the prediction value is 1 and the actual value is negative, that means it is predicting wrongly. So that is this 600. And the predicted value is negative, but actual value is positive. That means it is wrongly predicted. So 500. The predicted value is negative as well as the actual value. So that means correctly predicted. So this type of matrix is called confusion matrix. So you can analyze the how many numbers it is correcting, how many values it is predicted correctly and wrongly predicted. You can visualize with the help of this confusion matrix. For that, we need to import the confusion matrix from the thing. And then one more thing is that accuracy score. So these are the metrics. Okay, accuracy score. How much accuracy your algorithm based on the test result. Okay, and you can see now 57 values it is predicted correctly. 17 values it is predicted correctly. 0 and is also predicted also 0. But 5 and 1 is predicted wrong. So accuracy score for the test result as well as the predicted result will be 92%. So 92% your model is creating working properly. And finally, there is some visualizing training data set. So this is not much important. Not important because you cannot you will not use that in the project. Okay, so this is just to visualize your algorithm. So for your training part, for your understanding, we can see how it is. So there is a huge amount of code over here. So usually this is particularly designed for logistic regression. When you are using logistic regression, you can use this code. Okay. Only thing is you need to maintain this X train and Y train values. So other things are you can use it. Okay, so basically what this is, it is a mesh grid. Okay, it's a highly density grid, and step size is 0.25. So remember this one. So that means what step by step. So that means from 0.25, 0.5, 0.75 like that. Everything has been gridded. Okay, so it is not appearing properly now. So you may get properly. Okay. Actually, it will be like this. It will be like this. So what this means, it is classified into two. Your data set has been classified into 92% accuracy is there. So two classes. One is the customer will not purchase. Another one is the customer will purchase. The green area is the customer will purchase. The 0 area will be the customer will not purchase. So there will be some some exceptions in a data set. So that will be, you can see here some green dots on the red side and the red dot on the green side. So there will be some exception cases. Non-linear cases will be there. So with that, so this is just a visualization of what the data set is there. Okay. So nothing more than that. Okay.